I guess I'll kick us off. My name is Rachel. I'm a tech lead here at Offchain Labs working on Stylus, which we're going to dive into quite a bit today. Really excited to talk about it. And yeah, answer any questions you guys have too.
All right.
Hi. Are we doing intros? I'm Crisco. We're on I'm on the integration engineering team with Masa. We're here to answer questions for anyone that's trying to integrate Stylus into their tech stack. We're always available on the Discord, and also we have a Telegram chat for Stylus that's available. If you have questions on Stylus, we're always happy to help. So please reach out to us if you have any technical issues whatsoever. Thank you.
Hey everybody, I'm Austin. I'm on the product team, and I work on Stylus in a few different capacities among some other initiatives at Offchain Labs.
Amazing. So I start my questions by Rachel. So as a tech lead of Stylus team, Rachel, can you talk a little about what motivated the creation of Stylus and how Stylus was conceived? I witnessed the process, but it would be cool if you can talk about it for the audience.
Yeah, absolutely. Stylus initially started as kind of a weekend project. It was to answer a very interesting question, which is like, how can we, now that we have these really awesome WebAssembly fraud proofs, is there perhaps a way of like doing cryptography or some other kind of stateless computing quickly? That was initially what the idea was like, is there a way to like accelerate computation? And it turned out that not only could we do that and make cryptography and things like this quick, we can actually scale computing generally. Stylus, as you alluded to earlier, adds support for programming languages like Rust, C, and C++ to existing blockchains like Arbitrum One and anything else running the Arbitrum tech stack. But it was originally a bit of a smaller scope. But here's what we kind of have found from it. It answers a lot of the questions that one would want to in a scaling solution. Like, of course, it has lower fees and all of this. But I think something that's particularly exciting is how it lowers the barrier to entry to people actually wanting to build on Arbitrum technologies and just enter Web3 more generally. Like right now, if you look at this space, right, there's about 20,000 Solidity engineers, which, it's amazing what those 20,000 Solidity engineers have done. But when you think about languages like Rust or C or C++, there's like 3 million Rust devs and 12 million C and C++ devs. So essentially there's orders of magnitude more people. And if you're thinking about like, how do we bring Arbitrum to the world so that, we can have, millions of developers and all sorts of new exciting use cases as more and more people onboard onto crypto, Stylus essentially provides that, right? It gives you the ability to go take programming languages that you're already familiar with, say at a maybe you're doing traditional finance and you're wanting to dip your toes into Web3 instead of like having to go find a Solidity engineer and assess them and hire them and all of that. Now you can just take like the technologies that you're already familiar with and the processes that you have and deploy powerful decentralized applications using Stylus. So it's motivated by a lot of the things that one would care about, like lowering fees, but it was really nice to see that we also, out of this exploration, ended up figuring out that, hey, we can scale in a second way too, not just in terms of the actual raw performance, which of course the performance metrics are very, very good, over 10x in fact, in terms of lowering compute fees. But it also scales the number of developers, right? And I think Stephen originally said, if you want to scale to the next billion users, you're going to have to scale to the next million devs. And that is the question that Stylus fundamentally answers.
That's amazing. And Rachel, what do you think makes the Stylus contracts to be more efficient than Solidity contracts? And can you talk about how much more resources and computations will be available for devs?
That's a great question. So to answer how much faster first, it actually cuts compute fees over an order of magnitude. So as an example, right, if you were to do an add instruction in the Ethereum virtual machine, in the price that you pay for that, you could pay for 150 ads in the Stylus virtual machine. And actually, due to some improvements we've been making, that number might even get more extreme. My point here is that you get like 10x the computation, roughly, with Stylus. You also get 100 to 500x cheaper memory. So if you have an application that actually uses RAM, that's a component that computers have. Well, previously, when it comes to authoring smart contracts, doing generative art or anything using RAM in terms of cryptography was just cost prohibitive. But with Stylus, it's 100 to 500x cheaper. And then there's just generally like, cost savings across the board for other things like EVM affordances or, reentrancy detection, all sorts of really interesting things you would care about from the perspective of someone trying to make an economically viable app. If you're a price sensitive application like a perp or a DEX or really anything for which the fees really matter, like gaming, Stylus is the answer. And how we actually do that is very interesting. And it comes from a few different things. So the first thing is this. Programs written in Rust or C or C++ or any of the other things that Stylus supports use compilers that have had decades of research. So like when you go use, the Sol-C compiler to compile your Solidity down to EVM bytecode, it's amazing. It does some great stuff. But, when you go do the same thing in Rust or C, you're getting to use Clang and LLVM and all of these like industry standard tools for which, researchers in academia and, people in the industry have been working on optimization passes for and tooling support and all of this great stuff, right? So the actual code that you generate after compilation is substantially more efficient and higher optimized due to the compilers. But it doesn't stop there. So the other reason too is that the virtual machine itself is way faster. And to explain why that's the case, like when you do an add instruction in Stylus, you do an add instruction in the CPU using the assembly programming language that your CPU uses. So, on my computer, I run x86. On many, like if you were Raspberry Pi, you would be running ARM. These different what are called instruction set architectures in Stylus, an add translates to literally an add on that CPU in the language that hardware speaks. Whereas in Solidity, right, when you compile something down to EVM bytecode, that bytecode is interpreted by the EVM interpreter that your favorite client like Geth or Aragon or many of the other exciting clients that exist have to use. And so as a consequence, not only is the code more efficient that you generate, but the time it takes to execute those instructions goes way down. There's other architectural reasons why Stylus is cheaper, but the point of all of this is that this is some cutting edge stuff that just slashes fees across the board. And yeah, we're really, really excited should the DAO accept this proposal, watch as Arbitrum One, just becomes even more scaling and has so much more throughput and stuff happening because of lowered price of the things one would need.
That is amazing. Thank you very much, Rachel. So my next question would be for Crisco. Chris, can Stylus support any other languages on top of Rust, C, and C++? And we also had another question on the previous session about why don't we support popular languages like Golang or like JavaScript, for example?
Sure, yeah. So the beautiful thing about Stylus is that it runs on WebAssembly, which is the fourth language of the web after HTML, CSS, and JavaScript, right? So like being on the web makes it a ubiquitous target for a language to target for a compilation target. So that means that it's going to have the network effects of the whole web, which is billions of users. And that's going to incentivize most programming languages probably to seek out WebAssembly as a target to optimize for, and low-level compilers like LLVM and whatnot. So yes, the nice thing is about WebAssembly and Stylus's architecture is that it already supports virtually any language that does compile to WASM. There are some caveats to that. There are certain constraints in a blockchain environment that we have to watch out for. We need deterministic computation, so it makes things like garbage collectors difficult to work with because they can run differently on different machines and not necessarily free up memory in a deterministic way. So there are certain languages that are less favorable to working on Stylus, and that's why traditional systems programming languages like Rust and C are first class out of the gate. support it, but by all means, we can support any language that technically that will compile to WASM. There is another constraint that also you have to watch out for in blockchain environments, which is the binary size. So with like a programming language like Java tends to produce larger binaries, tends to require lots of memory for the garbage collector and things like that. So it makes it a little more difficult for things like that. But a lot of those languages have like stripped down versions that might be portable. Like JavaScript isn't probably going to be supported anytime soon, but there are similar languages like assembly script that code like JavaScript, but and it feels a lot like TypeScript more or less, but it does compile down into native WASM. It doesn't have the garbage collector, so you still get kind of the DevX of using like a TypeScript like language, but it ultimately has some minor differences in how it actually executes. And I'm being told by Rachel, which you may want to add here, is that we're likely going to support Golang soon. So I'll let her talk to that, since that's news to me.
Oh yeah, just really briefly. So we're starting out with just these 3 languages we feel really good about, but what's cool is any kind of systems programming language that compiles to WASM, is totally accessible. And there's nothing like special about how Stylus works that would, prevent different programming languages besides the general things like Kriska's pointed out, like binary size. So Golang, there's an effort to use a tool called TinyGo to produce very small WASMs that are free of a lot of the dependencies that a web browser might provide. And as this and WASI-Go, something that the Go team is working on, mature, Go smart contracts become very viable. And but the point that Kriska is saying is very, very true generally, that like, if it's like a really high level language with a big interpreter, a big runtime like Python or something, it's just not the best fit for blockchain. But if you're talking about something like Go or C or Rust or whatever, things that are used in a system setting and used for high performance code, even if Rust and C tend to be a bit faster than Go, the point is those kinds of languages are definitely on the table. And what's really neat too, by the way, that you can do at home, Stylus provides all of the VM affordances one would need to add a new programming language. So like there's someone actually made a Zig prototype that one was able to actually launch Zig contracts on. I think that was actually Raul here at Offchain Labs. But my point with that is that it wasn't like he had to make modifications to Stylus to add support for Zig. This is a programming language. It just works, right? And so if you're a programming language nerd like I am, and you've got a favorite language and you'd love to deploy smart contracts in it, reader documentation is absolutely possible and surprisingly easy. So eventually Stylus will have all sorts of languages that people might be interested and excited about.
Awesome. Thank you both, Crisco and Rachel. And the next question, Crisco, is what do you think makes Stylus different from other WASM-based and Rust-based execution environments like Solana or NEAR?
Sure. Yeah, that's a very good question. So yeah, Solana is probably known as, they've promoted Rust as a programming language for smart contracts for a couple of years now. They're probably the first one people would think of when they think of Rust smart contracts. So that is one similarity, in that you can code with Rust. We do choose different like architectural paradigms, like from Solana. Like Solana doesn't actually run on WASM. It does support Rust and C, but it doesn't actually run on WASM, which makes it difficult for them to expand and support other languages. Depending on, like Rachel mentioned, you'd have to go through a special process in order to get support for another language on the Solana ecosystem, versus like using WASM, we can support just anything that compiles to WASM as a low-level target. So that makes it nice for supporting other languages. There's also, like, in the Solana ecosystem, you're sort of in a silo apart from the EVM ecosystem altogether. Even the tokens, are completely different standard and not necessarily ERC20 compatible. So you lose a lot of the network effects of the EVM on something like Solana, where you can't really program things in a compatible way that can compose with other chains or other applications. And we're in a cross-chain world. It's very important to support those kinds of standards. I think that's a disadvantage for the Solana ecosystem, even though they have some nice things that they do. But I think that's one of their big disadvantages that Stylus does really well, because we expand on the EVM's capabilities and kind of compose nicely with it. I think that you get the best of both worlds, where you can program in modern languages like Rust and get a lot of the nice ecosystem features of that language, but you don't have to give up the compatibility with the EVM ecosystem, and that's super nice. As far as NEAR goes, NEAR has also other architectural choices it chose. Like, it does have an EVM. They supported EVM as what's called a precompile in their chain, where you can sort of like program a Rust contract and then have it talk to a Solidity contract on the precompile. But the thing is, their architecture is so different at the top level that it makes it very difficult to do composable contracts, because NEAR is an async blockchain and the EVM is a sync chain. So there's sometimes errors that come up in the NEAR EVM that are difficult to deal with from outside of that environment. So it makes the composable story a lot more friction. There's a lot more friction in composing EVM and Rust contracts in that ecosystem versus what we've done with Stylus. So I would say those are a couple of the biggest differences to point out there.
Awesome, thank you. I see a very interesting question in the chat, which is Stylus compatible with EVMs?
Yes, Stylus is absolutely compatible. And in fact, that's one of the big advantages of it that I realized when we were first talking about it in the beginning. We should probably have discussed a bit more. So Stylus, what's really, really cool and groundbreaking about Stylus is the composition. That is, you can actually write smart contracts in Rust or C or Solidity, and they all work together. That is on the same chain, right? With the same liquidity and the same community and ecosystem. You can have a Solidity DEX list a Rust ERC20 or a C NFT, right? Be listed on some, you know what I'm saying? My point is that all of these different applications and smart contracts can work together independent of the programming language they use. So, and the reason that is because it all uses the Solidity ABI under the hood. So when you actually call a Rust or a C program, from the perspective of the application calling you, the contract that is, it looks like it's just a Solidity contract. And in fact, using our tooling, which we provide, we have these nice tools you're able to use. You're actually able to take, for a given Rust project, you can export a Solidity interface for it, which, if you go import that into your Solidity contract, now you've got this like richly typed, nice way of interacting with that Rust program or smart contract, depends on what word you want to use there. But what's really exciting about that, right, is for the first time ever, like as Chris Goves is talking about when it comes to NEAR, Solana, or whatever, if you've wanted to write in Rust or C or one of these really cool languages with very efficient compilers, you've had to go to some other blockchain, right? Like you have to say, well, Arbitrum One has like all this liquidity, but I'm going to have to go make my dApp on some protocol that, maybe there's a way to bridge or something. But you get my point, right? There's all this friction. But Stylus, for the first time ever, says, here's Rust, here's Solidity. They all work together. They're co-equal. The same dApp can use a mix of programming language even. That's how tightly integrated all of this is. And it's all on the same network. And lastly, it's all fraud proven to layer 1. So all of this technology, right, taking advantage of our WASM fraud proofs, you get the security benefits of being a layer 2 with the performance implications of having these like all L1 technologies. And this is a really cool deal, right? Because it means that you've got like this high compute virtual machine and the Ethereum virtual machine, which, by the way, continues to work exactly as it did. Like if you've got a Solidity application you've written and deployed to Arbitrum One in the past, you've noticed, right, that the experience is pretty much identical to that on Ethereum L1. Well, that remains the case. So Stylus doesn't change the EVM, it adds to it. So we add a second VM. And in this manner, you're able to have it. If you want to just write everything in Solidity, you absolutely can. But if you want to, have a mix of things or call applications that use other languages, all of this is possible. And this has huge economic implications, right? Just the fact that it's all one tightly integrated, one liquidity, one community. ecosystem. And so is Stylus compatible with the EVM? Absolutely. And it, continues to, and it will always maintain that compatibility going forward.
Amazing. Thank you very much, Rachel. So Austin, I want to ask you about, is Stylus is a new chain, or can you talk about how our main chains, Arb1 and Arbnova, would fit into Stylus, or how Arbitrum Orbit is related to Stylus?
Yeah, absolutely. This is definitely relevant to a few questions in the channel too, which I'm happy to answer. So the short answer is no. Stylus is not a new chain. It's actually an upgrade to existing Arbitrum chains, and will be included in the kind of canonical Arbitrum Nitro tech stack. So like to answer one of the comments in the channel, like, no, there will not be an airdrop for Stylus, but that's okay because Stylus is bringing its own value in many other ways and is an exciting upgrade to existing Arbitrum chains that already have so much built on top of it. So yeah, it's interesting to think about like, how does Stylus play into the existing Arbitrum chains, whether that be Arbitrum One, which is what most people are familiar with, or Arbitrum Nova, which is kind of a like gaming specific chain with lower fees. So the way I see it is, given the DAO approves and enables Stylus on these DAO governed chains, there's just many new use cases that can be brought to Arbitrum One and Nova. Like for Arbitrum One, like Rust, C, C++ developers will now be able to access the $8 billion of liquidity and ecosystem of 500 plus apps that are already present on Arbitrum One. While users will get access to all these new use cases uniquely enabled by Stylus, as well as like gas savings for anything that they choose to do that is leveraging like the efficiencies of WebAssembly-based smart contracts. And then there's Arbitrum Nova, which is a great option for developers who require ultra-low transaction fees. And so for anyone building an app with like a high volume of on-chain transactions, so like whether that be a game where you're, making transactions for every action you're doing, or a social app where you're making transactions for every post, like using Stylus on Nova with all of its infrastructure that is already supported on there, including like fiat on-ramps and fast bridges and centralized exchange withdrawals, account abstraction providers, and really everything you need to be successful in building an app. Stylus can basically take that for a developer's advantage, and be useful for like any new use case you want to use it for on there, whether it's building like a custom like modding engine for video games where people can now, take an on-chain game and customize it with Rust or C mods. But yeah, okay. So Orbit is an interesting one too, because yes, we have one in Nova, but for the most part, they are general purpose blockchains. They, are meant to serve a variety of different use cases. And I guess for those that aren't aware, like Orbit is the permissionless path for launching customized, dedicated blockchains, and anyone can do this. And so what this means is you can push Stylus to its limits, like whether it be like higher contract size limits or higher throughput, or cheaper costs. So like what I'm excited about to see is like these use cases that actually aren't possible on the existing Arbitrum chains, even with Stylus, you can now go a step further and extend or expand upon these use cases using Stylus on these customized chains built for like a specific use case. So yeah, exciting.
Yeah, very exciting. Thank you very much. The other question is, Austin, I know you are working with a lot of teams who are building on Stylus. So can you talk a little about what do you know, what is being built on Stylus, and what is the reason they're choosing Stylus as a platform for their implementation? Is it because of the benefits? What are the benefits that Stylus provides for the ecosystem and for the users?
Yeah, absolutely. So yeah, let's talk a little bit about what's being built with Stylus already today on testnet. So one fun example is sort of a use case that just isn't really feasible in the EVM are private peer-to-peer transactions, which are like sort of a new decentralized exchange mechanism. So if you can imagine somebody who wants to make a buy order or a sell order, but does not want to, one, experience slippage because of limited liquidity, or two, be exposed to like MEV because blockchains are like inherently public. So like whether even in the Arbitrum case where like there is a private mempool which protects users from front running and sandwich attacks, there is still back running and arbitrage. So if you can find a way to have private peer-to-peer trading, you can actually avoid one, slippage, and two, MEV. And what uniquely enables this are zero knowledge proofs. So like if somebody places a buy order, nobody besides a person who placed that order actually knows about it, including the person on the other side of the trade. They are placing their own order and they get matched programmatically. And so what's fun about this use case is that like this zero knowledge proof that is kind of enabling this privacy turns out is a lot cheaper when using Stylus than a Solidity implementation. And so this team is building out this use case meant for like Arbitrum chains once Stylus is enabled. And they, chose to use Stylus because it simply just isn't feasible in other parts of the EVM. And so the benefit to users is that they, get this brand new use case that isn't present on other chains on top of Ethereum, and they, have access to this new tool that allows them to make trades with no MEV and no slippage. And to be clear, this isn't going to be the most realistic option for most users, but for those that are trading a lot of funds, like this may be the best option for them. But I think it's important to note that like, being able to verify a ZK proof on chain using Stylus makes it a lot cheaper. And there's a lot of talk about, ZK rollups and, advantages and disadvantages against optimistic rollups. But I think we very well may see like this narrative form that the best place to build zero knowledge apps may actually be on an optimistic rollup using Stylus. So yeah, thanks. I'll leave it at that.
Thank you. Thanks. That was interesting. So Rachel, can you talk about what kind of design space does Stylus open up for Arbitrum chains at a protocol level, please?
Absolutely. Some of the teams Austin's talking about, are already jumping in on some of this stuff, which is really exciting to see. I think there's a few things. So, not only does Stylus introduce like all these new awesome applications you're able to build, but if you're thinking about it as a protocol, like how you think about a chain like Arbitrum One changes should the DAO adopt Stylus. So, right, if you're someone building, say, some next gen ZK technology or whatever, or you've got a bridge that you want to build that involves some very specific cryptography. having the ability to deploy some of your bridge contracts in Rust or C or what have you is really empowering, right? Because it means then that, like, from the perspective of someone building an orbit chain or something, targeting Arbitrum One becomes much easier than targeting a platform like Ethereum, right? Or any other just solely EVM chain. You know, right now, a lot of the people who would target Ethereum or any of the other, EVM chains, you have to deal with the cryptographic primitives that the Ethereum virtual machine provides, or Solidity, or some combination of these things, right? And with Stylus, you can literally just go on Google, find a reference implementation for your favorite cryptography, and deploy that as is to the chain typically. Usually you don't have to make any modifications, or if you do, it's like really minor. And once you've deployed your C contract, right, that maybe implements a special elliptic curve or some kind of ZK verification or whatever, you're now able to extremely efficiently execute those contracts on a protocol level, right? So if you're like building your L3 and it's got like all this super interesting orbit tech, right? It can now target Arbitrum One in a very unique way versus other platforms. So when you're thinking about protocols, this is really interesting. And I see somebody asks, so literally Stylus is categorized as an optimistic rollup. Arbitrum chains are optimistic rollups, and Stylus is an upgrade to it. But what's neat though is that, like, just because it's an optimistic rollup doesn't mean you're not able to introduce these really powerful other technologies too. So if somebody has that, like as Austin's pointing out, that like cool ZK market idea, right? Like that stuff now becomes viable on our chain because of the fact that you would have access to all of the all of the nice cryptographic primitives, assuming the DAO adopts the upgrade, right? So when you're thinking about the protocol level, the sky's the limit. It can only be more empowering, right, to have access to these kinds of tools. And I'm particularly interested in a lot of the privacy things people are building, and other just interesting use cases of a chain where compute becomes a way more accessible, without fees jumping up. So, yeah.
Amazing, thank you. And you mentioned that Stylus builds another virtual machine on top of the EVM. So can you talk about what are the security implications around building a separate VM? And is it going to affect the fraud proofs that we have live now? Or
that's a great question. So Stylus is fundamentally two virtual machines. You have the Ethereum virtual machine on one hand, that remains unmodified. And then we introduced this new WASM Stylus virtual machine. And these two virtual machines work together. So if in the middle of a transaction, you're running some Solidity code, that EVM bytecode is executed by the Ethereum virtual machine. But if that EVM bytecode says, hey, go call the Stylus program, it will then switch to the Stylus virtual machine and execute that part of the transaction. And in this manner, the two VMs pass execution back and forth, creating the state transition that a transaction says to do. And it's super cool that it can work like that. And what's nice is how modular that experience is, right? Because Stylus isn't just like hacking up the EVM and making all these modifications where we're trying to have somehow one VM do both, right? Having each dedicated VM separate means, in terms of security, the code is just so much less complicated. I mean, don't get me wrong, Stylus is a complex upgrade, but all of it is like in its own separate part of the code base. And so when you're thinking about it from like an auditing perspective or security analysis, or just understanding code and making it a tractable problem, having the EVM stay pretty much exactly as it is, and then Stylus over in a separate, coherent manner, makes it, from that perspective, very easy. But then on a protocol level, right, Stylus uses the same WASM fraud proving technology that Arbitrum Nitro brought to blockchain. And what's really cool about that is it means that like the actual security assumptions of the chain do not change. It's still an optimistic rollup. It still uses fraud proofs. It's just what we're fraud proving is a little different. In the past, we might fraud prove or right, I suppose I should say prove fraud over Geth, right? Maybe somebody lies about what Geth does. But in this case, we're now able to prove fraud over user programs. So if somebody deploys a smart contract that does some really fancy elliptic curve cryptography or whatever, I clearly like cryptography quite a bit, but of course you can apply this to anything else, right? Like when it comes to nice financial primitives or generative art or any other thing that has a lot of compute. Well, if someone deploys a contract that uses Stylus as a technology, and there's a dispute about it, right? The fraud proof mechanism resolves what that contract did, much the same as it does what Geth might do for a TX that runs in the Ethereum virtual machine. And so, no, Stylus does not change the security assumptions of Arbitrum One or any other chain that might adopt it. And by the way, it's also under audit right now. So when we're thinking of security implications, it's under an audit. It's going really well, and yeah, we're excited to put the finishing touches on this and make this and upgrade that. Chains that are still fraud, that are still optimistic rollups, will get to continue being so.
That is very interesting. Thank you, Rachel. So if VMs and languages are different, Crisco, can you tell us if that's going to affect smart contract developers, or does it make certain things incompatible, let's say between Rust and Solidity?
Sure. Yeah, like Rachel was saying earlier, I think one of the most beautiful things about Stylus, and it really is probably the most seamless experience of like pairing two VMs that I've seen in the blockchain ecosystem, where you're able, because ultimately we do ultimately use Geth. We rely on Geth for storage at the low level. So whenever your contract is getting stored, it's getting stored in the same database that Solidity contracts get stored in. It's using the same storage model that Solidity contracts are using. So I think a lot of those things make it super composable and make it super compatible with EVM. And when you're using our like Rust SDK, for example, the way we do it is we have integrated a library called Alloy, which is from the Foundry and Ethers RS teams. And essentially it sort of maps Rust types to Solidity types and allows you to like seamlessly switch back and forth between them. So it allows you to easily port contracts over from Solidity into Rust, and you can just variable for variable like declare your types, and it will have the same memory layout in your smart contract as the Solidity contract will. So that makes it super nice to develop on, and makes it very compatible with any tooling that's out there, like Foundry. Like if you want to use CAS to call your contracts, or you want to inspect the memory of your contract, if you've got the schema, you're able to do that with existing tooling, and it's just super smooth and really easy to use for that. So I think, and you also have the flexibility to go outside of those paradigms if you want to. But if you want to keep things in the Solidity compatible way, our SDK makes it easy to just sort of like fall into that and make that work with the existing ecosystem. So it makes it super easy. But yeah. So certainly for the vast majority of tooling that you would use, everything's compatible.
Thank you. And you mentioned the Rust SDK. I want to know what was the reason that Rust was chosen as a language for the most SDK support? Is there anything that Solidity does better, or?
Sure. I think Rust is modern. It's a super nice modern language. It's come out in the last 10 years really, and it started to mature, and it's starting to be used in low level programming in at all the big tech companies, Microsoft, Google, Apple. Everyone's using it, and they're starting to transition. Even the Linux kernel is starting to introduce Rust. So it's starting to get to be ubiquitous, where it's got like Rachel mentioned, there's a couple million developers that are already familiar with Rust, and so it's also like it's getting that mainstream adoption, but it's a more modern language than C or C++ is. So it's got a lot of nice modern features that make it feel like a language. It's almost as if you're programming. It feels like you're programming in a language with a garbage collector, even though you don't really have to worry about allocating memory or doing any of these lower level things per se with Rust that you might have to do in C. So I think I think that just the general like developer experience of using Rust is superior for the trade-offs that we need to work with. Like we need to produce smaller binaries. We need to not have a garbage collector. So Rust is like this nice, nice general purpose language that I think is powerful for programmers. It enables a lot more design space as far as like how you can develop programs versus Solidity. Like I think that Solidity is a very constrained language. It's a special purpose language versus Rust is a general purpose language. And while that might make it a little more straightforward into how you might architect your smart contracts, um, it also, I think Solidity has a lot of like foot guns, for example, that Rust doesn't have. It's you're not going to accidentally overwrite a type in Rust. The checker is very strict, and it will let you know whenever you try to override or accidentally do something. That I think in Solidity, a lot of things will just silently you'll accidentally override a variable, and we've seen so many exploits over the years, and while the ecosystem has developed quite a bit of scar tissue and best practices to sort of get around that with Solidity, they still exist and they still catch new developers, especially where they might like overuse storage and waste gas, or lots of different things that Solidity doesn't really help you with. So I think Rust is nice for that. It is very efficient, and it just has a lot of nice trade-offs that are really good for developers. And are there some things that Solidity does better? I think probably the only thing you might argue that it does better is probably like the binary size is smaller in general with Solidity contracts. But that is a constraint that I think that we can, I think the benefits outweigh like the minor, one time cost or one time overhead of like maybe pushing a slightly higher binary size versus the Solidity contract.
Amazing. Thank you very much, Chris. So, Austin, from the product point of view, if somebody wants to build something on Stylus, can you talk about when does it make sense to choose Stylus to build on, and when it doesn't make sense, in fact?
Yeah, absolutely. So I think Stylus makes the most sense if you are building like a new use case that is not feasible in the EVM. This is kind of where the design space is still wide open, and developers like today, right now, still have the opportunity to be incredibly early to a new technology. Like to reiterate what's already been said, like Stylus is the first time that you're able to write smart contracts in these like WebAssembly based smart contracts or WebAssembly based programming languages, whether that's Rust or C or Golang, that is still interoperable with the EVM and gets you access to all the liquidity and ecosystem and infrastructure already on existing EVM chains. So like this opportunity is still very much wide open and for the taking. I think that Stylus like can also make sense for rewriting existing use cases in a more efficient or safer way. For example, like there is a team building a concentrated liquidity AMM, similar to Uni v3, but in Rust. And they very well like may have claim to being the most gas efficient concentrated liquidity AMM compared to everyone else. And this is like important because a lot of people trade through these kind of decentralized exchange aggregators. So like even being able to do a little bit cheaper than the competitor can actually get you a significant share of order flow. But yeah, and then like, Stylus may not make the most sense if what you're building does not require much, if at all, like computation or memory. Like storage largely costs the same across like Stylus contracts and like EVM contracts, since this data has to be posted to L1 Ethereum regardless of what you're doing. So something simple like, you know, an ERC20 token may not get you the same tangible benefits using Stylus as some more complex smart contracts would.
Amazing, thank you. And if somebody wants to use Stylus, can they start using it today? And can you tell us if there are any grants available for developers or people that are interested for?
Yeah, definitely. So Stylus is usable today. There is a standalone Stylus testnet that is like open to everyone to start developing with. If you go to the docs, which is just located at docs.arbitrum.io, there's an entire section for Stylus with all the details about the Stylus testnet. You know, a quick start for just getting started right away. You know, further details into the Rust SDK and C SDK, and basically everything you need to start using it. So like definitely recommend, like, if you're a developer interested in this technology, to, you know, get started with it as soon as possible. And then on the grants point, yes, there are grants available. I will note that this is like a bit separate from like the Offchain Labs. This is run by the Arbitrum Foundation. But there's a few different paths here. So one is like there's a grants program. Anybody can apply to it. If you're building something on Stylus, there are like specific tracks that you can apply for, which like may make you more or less eligible to receiving a grant. So that's one option. There's also another option, which is sort of an emerging structure for like RFPs, requests for proposals, for specific like things that the foundation wants to see built, rather than just like someone coming and applying with their own idea, which like I think is amazing too. But this is just an alternate path if somebody would like to, is interested in, or kind of wants to fulfill a bounty almost to building something for Stylus. That's another option. And then the third option is like just actually going directly to the DAO and proposing your idea and a grant amount there. So there's a few options that can kind of work for everybody.
Amazing, thank you. That was a lot of good info. So can any of you talk about what is the roadmap? What are the next steps for Arbitrum Stylus?
Yeah. So in terms of the next steps, right now, Stylus is being audited. That's our primary focus at present. You know, security comes first with everything we do. It's the reason why every chain that Offchain Labs has ever, you know, launched has had fraud proofs from day one. And so as a consequence, just, you know, in that same thinking, the audit is our primary concern. But that is going to end soon, and then we will transition to proposing this to the DAO. So recall, Arbitrum is a decentralized community. We don't have control over it, nor would we want to. And so what we're going to do is propose that the chain, Arbitrum One and Arbitrum Nova, adopt Stylus. And so that will be a DAO proposal, just like any other that you might see. A bit larger in terms of its technical size, but fundamentally it's the same thing, right? So token holders will vote on it, and you know, should it pass, it then will become part of how Arbitrum as a technology works, and the various chains that adopt it will be able to. So that's like our plan for it. But at the same time, once we feel that it's ready for the DAO, that also means that if an Orbit chain wants to just go and use it, they can, without having to do a DAO vote or anything. Recall that those who are using Orbit as a technology, you know, are able to just deploy whatever modifications they want to their rollups. It's a permissionless system, and so because of this, you know, if you want to adopt Stylus, you can just go ahead and do that. And so basically, we're just completing Stylus as a technical upgrade. We're also going to improve the SDKs. So we're going to add more features that are commonly requested and add more support and love for languages like C or C++, just making those SDKs on par with the Rust one. And yeah, just get it to where this stops being just a test net and becomes a living and breathing product on all of the different chains that choose to adopt it. So that's currently our plans. I don't know if anyone has anything they want to add to that, but.
Sounds cool. It sounds really interesting. So I'm done with the questions that I initially had. Let's go see if there's any questions on the chat, or I can continue asking questions from you guys. So what are the benefits of Stylus for a user other than cheaper fees? Is the users also senses something else than cheap fees?
So here's the cool thing. Stylus benefits you not just because the fees are lower, but because you get to use other programming languages. This has a few implications that are really cool. One is that more dApps that you're interested in, particularly from chains that don't use the EVM, might become available. We happen to know many that we're talking with. And what's really cool about that, right, is we can actually now have applications on Arbitrum chains that are written in different languages, and where there's existing code, they get to benefit from that. It's true that from a user's perspective, this all just looks the same, right? Like, so when you're using your favorite smart contract wallet and, you go and you buy an NFT or you trade some coins or whatever, right? Like, it all is the same experience. I mean, yes, the fees are lower, but it's all the same experience. But my point is that the kinds of experiences that become available to you are going to increase, right? You're going to see more generative art. You're going to see some really cool perps. You're going to get more complex financial primitives. My point here is that, yes, even though when you hit sign on your wallet, it's all the same thing, right? Minus the fees. But what you're actually doing, right? The dApps that you're using, the things people are building, it'll just be a broader set of experiences that one can have on an Arbitrum chain. So if you're thinking purely from the user's perspective and not the dev's perspective, that would be the answer. But also, you're going to gain more confidence, I believe, in the correctness and safety of dApps. Of course, audits are still super important and all of that. But something that we're finding actually from auditors that's been interesting is that Rust smart contracts are much more fun to audit for the following reasons. In Solidity, a lot of devs are they do what's called code golfing. So you might make all of these really ugly or hard to think about changes to your Solidity contract to eke out a better set of fees, right? Like to just save a little bit of compute, to save a little bit of storage or whatever. People go through these great lengths using assembly and other very dangerous constructs to build the dApps that they do. And you'll even find that people allow reentrancy by default often just because, well, right now in the Ethereum virtual machine, it's very expensive to deny reentrancy from the outset. And so, or really detect and deny it. So my point with all of that is right now when you're building smart contracts, it's a bit more dangerous, right? But with Stylus, the Rust compiler or the C compiler, right, they're going to be able to generate much more efficient code, much more optimized code than you will by hand. And so you're not going to see devs hacking up for loops or whatever to try and eke out another 5% or something from the Sol C compiler. And what that then translates to from a user perspective is the applications you're using, they still need to be audited. You still need to make sure that contracts are verified, all that good stuff, right? But my hope is that over time, what we'll see is the community become a bit more safer, right? And that accidental error will become harder to make in a blockchain setting. So so from a user's perspective, it's these are more qualitative changes, but the quantitative change that's really easy and obvious is just that the fees are lower.
Amazing, thank you. So we have time for one more question, which is, how is gas estimated in WASM contracts?
I guess I'll take it. So gas estimation, here's something really neat. In the EVM, every opcode has an amount of gas associated to it. So for example, if you want to add two numbers, you pay 3 gas. Stylus does something very similar. So in Stylus, all of the different WASM opcodes have an amount of gas that they cost. We use a term called ink, which is essentially a fraction of a gas to pay for these opcodes. After all, if you're able to do 150 Stylus ads in the course of an EVM ad, right? Well, there's no such thing as fractional gas. So if you were to take 3 and divide it by 150, right, that is not an integer. And so we had to introduce this new notion called ink. From the user's perspective, when they're estimating gas, all the stuff happens behind the scenes. You don't have to think about gas estimation. But what's cool is this, okay? Every opcode has a cost. And unlike the EVM, where you pay the gas for an opcode and then you run it. And then you pay the gas for the next opcode and then you run it. And then you pay the gas for the following opcode and you run that. In Stylus, you pay for entire batches of opcodes all at once. So let's say you've got a block of a bunch of instructions, assuming that they're control free. This is a control flow free. This is a thing that you'll see if you actually look into the architecture of Stylus. You pay for all of those instructions at once. So you pay for a batch of instructions, then run it, then pay for a batch of instructions, then run that batch. And in this manner, we're actually able to cut fees even further. So I recognize that this is getting particularly technical, but that is fundamentally how gas works. It's a technical concept. But what's neat is all of the stuff is done automatically, right? So like from the perspective of somebody actually transacting, all they notice is that the fees are lower, but under the hood, this is how it works.
Amazing. Thank you very much. So I guess, yeah, we're kind of close to the end of the session. And I appreciate you three. It was really interesting to hear your thoughts and everything about Stylus. And I'm very excited about the next steps. And yeah, what comes next is very cool.
Yeah,
So
I think that, sorry, just to add that we have a Stylus Discord channel
Yeah.
in the broader Arbitrum Discord channel, or it's a Stylus channel in the Arbitrum Discord server, and then a Telegram channel for Stylus developers as well. So please reach out to us in those verticals. Thank you.
Yeah. Thanks. Thanks, Austin.